Okay, we are in 2.4 College Algebra, and this is called Analyzing Graphs of Quadratic Functions. Now, if you remember, clear back in 1.7, we were doing different graphs and how they shifted left or right, or moved up or down, or revolved around the origin, or reflected across an axis and all that. Well, it's kind of where we're going with this one, just a little bit. Just to give you kind of an idea of what we're going to do, we are going to graph two different types of functions. One is going to be something that is in this form, and the other one is going to be in this form. Where a is not equal to 0. Alright, so we're going to be looking at these two different types of functions. So, first of all, we're going to do this top one, so let's get rid of the second one. We'll come back to it later. So what we have to do here, and maybe I'm getting a little bit ahead of myself, but what we have to do is whatever equation we have, we're going to have to change it into this form so that it is easier to graph. Alright, so let's go ahead and do some definition stuff here. First of all, when we are doing a quadratic function, it will always make what is called a parabola. And a parabola, if we have a graph, looks like this. It'll either look like that or it'll be upside down like that. Okay, it will not be that way. Those are hyperbolas. So a parabola looks like that. Either opens up or opens down, depending on a couple things we'll get into later. Alright, so what we're going to do is look at the formula, or the function, f of x equals x squared. Now that is the building block that we're building this off of, okay? And just we talked about building blocks earlier, and same kind of idea. So what we're going to do is we're going to do some things to it. So if I have an f of x and I put an a in front of it, okay, so see I put an a right there. Alright, if I put a number in front of the x squared, that gives me a vertical stretching or shrinking with a reflection across the x-axis if this a is a negative number. If this a is a positive number, it'll stretch or shrink. If the a is less than 0, if it's a negative number, then it will not only stretch or shrink, it'll also reflect across the x-axis. Okay, so what happens if I take my x and I put an h in there with it? Okay, that means it's going to be a horizontal translation. It's going to move this way or this way. Okay, now what happens if I take this and not only multiply an a and subtract an h from it, but I also add a k to it? This k gives me a vertical translation, up or down. Okay, so depending on what happens. So let's look at this. If we put a number in front of the x squared, it is going to vertically stretch or shrink this way. If this a is a negative, this number is a negative number, it will flip it across the x-axis. If we take that x squared and we subtract h from it first before we square it, what does it do? We get a horizontal translation. It'll move it along the graph left or right. It'll stay the same shape, it'll just move it left or right. And if we take that whole thing and add k to it, it'll move it up or down this much. Okay, so that's what we're going to do here. So let's look at a little bit of how this all works by giving you a bit of definition here, if I can erase some of this stuff. Alright, definition. We already talked about a quadratic equation making a parabola. And another thing that we're going to do is look at HK. You saw that in the formula I put up there. And that is called the vertex. That's the point of the vertex. So if I have, let me get a graph out here. Okay, so there's my graph. And if I have a parabola that does that, my vertex is right there. That's at point 3, negative 3, right? This is my h, that's my k. My x coordinate is h, my k coordinate is my y. It's just a way to say, all right, we're looking on a graph, we're looking at coordinates x and y, but we're talking about a particular coordinate, which is the vertex, and we're going to call it hk, just to be specific here. Okay, we also have something right here. We have a dotted line that goes through the vertex, and that dotted line is called the axis of symmetry, not cemetery, symmetry, and it has two M's there. And that axis of symmetry is where the parabola is symmetrical. It folds right across that dotted line there. Okay, one of the things that you need to see here is the axis of symmetry will always be the x-coordinate, the first coordinate of the vertex, because it goes through the vertex. So if you've got a vertex of 3, negative 3, you know your axis of symmetry, which will always be a vertical line, will be at that point, that 3. So what that means is x equals h. Okay, so where this goes over to 3, that is our h. So that's the axis of symmetry. All right, we also have minimum values or maximum values, not both. Minimum value or maximum value will always be the vertex. This one is a minimum value. The lowest point in this parabola is right there. So the minimum value or maximum value will always be the k. Okay? So, k, is the maximum or minimum, the y part. Okay, the second number there. All right? Okay, so one of the things I want you to understand is that I had some numbers. Well, let's put the formula back up here, and that's f of x. All right, let's look at this a right here. All right, interesting thing that a is. If that a is a number that's greater than 0, then the graph will have a minimum. If a is less than 0, then the graph will have a maximum, which means this. Let's see if I can get rid of... all right, let's move everything out of here. There we go. Okay, so if we have a is greater than 0, then we have a minimum. That means our graph is going to be like that, has a minimum value. If our a is greater or less than 0, then our graph has a maximum, which means it opens down. So this means it opens down, this means it opens up, because the minimum value is the lowest part, which means it goes up on both sides. The maximum value is there, which means it goes down on both sides. And that is if a is a negative number. If a is a negative number, it opens down. If a is a positive number, it opens up. Okay. As the absolute value of a increases, so what that means is as this number gets bigger, so if this were 3, 4, 5, what happens to the graph is maybe on 3 it'll look like that, on 4 it'll look like that, and 5 it'll look like that. So see how it's narrowing? The distance between here gets smaller and smaller as that number gets bigger and bigger. And as this number gets smaller, the width of this gets wider and wider. Okay? Until it gets to 0. See, this is I don't know. All right. I'm a math geek. Let's see what happens here. So as this number here gets smaller, my graph gets wider and wider as that number gets smaller. So maybe it's like until it gets so small, it goes to 0, and then it goes to negative, and then what happens is it flips this way. Okay, and then as that gets more and more negative, like negative 10, negative 12, negative 15, negative 20, it gets narrower. So it gets wider and wider and wider until a is 0 and it quits becoming a parabola. It becomes a line, so it's not a parabola, and because this number can never be 0. And then when it comes negative, then it goes the other way. It goes down, or it opens down. So isn't that just really like the coolest thing you've ever seen? All right, so I'm going to stop here, and we're going to actually do some work with these guys.